Let's look at this question. There is a smaller block which is kept on the top of the bigger block. Okay, and the whole system is placed on a ground where the frictional coefficient is mu between the bigger block and the ground, and the smaller block and the bigger block m have a frictional coefficient of mu by 2. Okay, in between them. Now the whole system is pushed towards right with the velocity v, initial velocity v, and they are asking what time it will take for small m block to separate from the bigger block. Let's find out that. Now the first thing that we should understand here is what happens when you place a object on another object. What will happen? See, if you place on another object, placed another object on a larger object like this and push this object towards right, there will be a frictional force experienced by this small m block, right? Now, if the small m block frictional force is such that for example the small m block is moving along with the capital M block, then this frictional force will be towards right. Okay, that's why it is going towards right. If I take this whole system slowly towards right, you imagine that if I am taking this whole system slowly towards right, then this block will be moving along with this capital M block towards right. The friction will be towards right. That's what is taking it towards the right direction. But now the question is, if it is so, if it is going slowly, then it will never separate, right? So what should happen if it has to separate? When there is a separation, that means there must be a slipping, right? So if the slipping is happening for this small m block, that means it is experiencing a limiting friction. Now that limiting friction will be towards left, and that value will be mu mg, that is the mu times normal reaction. Sorry, it will be mu by 2 because the coefficient between them is mu by 2, right? So there is no right direction force, okay? But still it has to go towards right because it has an initial velocity v. It is like a deceleration. Okay, so now for the free body diagram of small m block, you have a force which is solely towards left direction, that is mu by 2 mg. Now let's come back to the bigger block. So what will happen for the bigger block? If I see here for the bigger block, the free body diagram, now there will be a rightward direction force mu by 2 mg because of the smaller block, right? Of course, every action has an equal and opposite reaction. So it will, small m block will push this capital M block forward. But now there is a friction between the bigger block and the ground as well, which is having coefficient of friction as mu. So it will be mu times capital M plus small m into g, that will be towards left direction. Okay, so here the net force, if you ask me, on the small m block is lesser compared to the big block M. You can see if you subtract this mu m plus mg and mu by 2 mg, you will get mu mg by 2 plus mu capital mg. So this capital M, for this bigger block M, more frictional force is there towards left compared to the small m block. And that's what going to happen, because then what will happen, this small capital M block will come to rest very faster compared to the small m block. That means small m block is going little faster than capital M block, and it will fall off after certain time, right? Okay, so that time we have to find out. So to find out that, we have to find the acceleration. So the basic idea is, what I will do here is I will take the acceleration of capital M, and I will make this capital M block to the rest. Okay, I will see the relative to capital M block, the situation of small m block, and of course there is a length given for this block which I forgot to write. It is L. Okay, so now I will see the situation of small m block with respect to capital M block. So first let's find out the acceleration of small m. It will be mu by 2 mg by m. So it is in left direction, so I'm writing minus here. I can write that mu g minus mu g by 2. Now write acceleration of capital M. Acceleration of capital M will be mu by 2 mg minus mu times capital M plus small m into g. Now divide by capital M because we need acceleration. So I will divide it by capital M. So this will be mu by 2 m by capital mg minus mu g minus mu m by capital M into g. Okay. So now this will be minus mu by 2 small m by capital M into g minus mu g. So this is acceleration of capital mass M. Now we want to find out the acceleration of small m with respect to capital M. That will be am minus capital Am. Now am is minus mu g by 2. You subtract minus mu 2 by small m by capital mg minus mu g. So this will be equal to mu g by 2 plus mu m. I think this is small m, right? So let me write small m here. Small m by capital M into g. So this is why this is mu g by 2. You just add this. Minus minus will be plus mu g minus mu g by 2, which is mu g by 2. So this is the relative acceleration. Acceleration of smaller block with respect to the bigger one. Now for this smaller block, for the bigger block, the smaller block will cover the distance capital L with this acceleration. Okay, so this acceleration is with respect to the bigger block, right? So with respect to bigger block, this small m is experiencing this much acceleration. So now I will write the relative acceleration. Okay, relative displacement. Displacement of small m with respect to capital M is equal to initial velocity of small m with respect to capital M plus half into a small m with respect to capital M into t square, right? So the distance or the displacement of small m with respect to capital M is L, which is simple. The initial velocity will be 0 because both of them were moving with the same velocity v, right? So that will be 0. Now plus half into this acceleration. So I can take mu g outside. Okay, this is mu g, this is 2 factor over here, I forgot. So mu g by 2 I will take outside. So it will be 1 plus small m by capital M into t square. So this will be L is equal to mu g by 4 into capital M plus small m divided by capital M into t square. So this is the time. T square is equal to 4ml divided by mu g into small m plus capital M. So from here you will get the time t to be square root of 4 capital ml into mu g small m plus capital M. This is the time it will take for the block to separate from the bigger block. Okay.